Okay. So kids, just a few things before we start our seminar, things that I want to show you. First of all, super important that when the first thing you do every day, every other day, is to go onto our home page, check the announcement. So of course, I've posted an announcement, but you should always be aware that your seminar days are on day 5 and day 10. So please check the announcements on those mornings. I have written an important announcement about consultation, which says that for all grade 9s, you should not just consult for the first time at the end of your unit guide. You should be consulting. Sorry, I'm just going to make sure my mic is on. Yes, it is. You should be consulting after every assignment or after every 2 assignments. That way, Miss David and I can check that you're doing your work correctly. We really do not want to see you at the very end for the first time, and we will be communicating this to your parents on Meet the Teacher night. I want to see you after you've done every single assignment. So that should be clear, and there is an announcement about that on my D2L. The other item that I want you to know for your content page, we repeat this quite often, but if we go down to, for example, Unit 5, you have your unit guide there, but you also have your Unit 5 lessons. So the seminar notes are here. If we go into collecting like terms, you just have to, oh, there it pops up. These notes should be in front of you when you are doing your Unit 5 guide. You should put the question portion so you can see how I am doing my steps. You should also do your steps the same way. Once you finish that portion, if you're moved on to adding and subtracting polynomials, this should be in front of you when you are doing your unit work. So many times I see on my floor time that a student is showing one step. But clearly, when I did the problem in my seminar, I showed 4 steps. So it is very important that you show as many steps as possible on your test as well as your unit work. You never just write the answer. Is everyone clear about that? By the time you get to grade 12s, my grade 12s right now are doing a concept called derivatives, where there are 10 steps minimum for a complex derivative question. So we have to start slowly building over the years the skills that you need so that when you get to grade 12, you can handle that, okay? That's why we are reinforcing the importance of steps so much. Okay, I am going to backtrack a little bit. So, especially because I'm recording this seminar, I do want to give a little background knowledge, and I'm going to zoom in a bit more. So I covered a little bit of this in Unit 5, but I think that it's important as part of Unit 6 to remind you again. So we, in your Unit 5, we call this subtracting polynomials. It is also called the distributive property. So can everyone just make sure you have the definition in your notes about subtracting polynomials, and we're going to compare that to the distributive property shortly. I have to just plug in my computer and make sure we're good to go so that I can write on the smartboard. Okay, give me 1 second. Okay, that should work now. Yes. So to subtract polynomials, one method. Only one method is to add the opposite. So we would switch the signs. That's what you did in Unit 5. So you would turn it into an, just to review in Unit 5, you would turn it into an addition problem and you would add the opposite. We're going to do something different today, and the whole purpose of this seminar is the distributive property. So I'm going to solve this same question using the method that you will be sticking to for Unit 6, which is called the distributive property. Give you a second to write that down. So please be clear in your notes that this adding or subtracting polynomials by adding the opposite is a Unit 5 concept. Unit 6 concept is exclusively distributive property. So I'm just going to show you what I'm talking about. So in Unit 5, we taught you to add the opposite by changing this 3y plus 5 to positive, and then we would change the signs inside the bracket. What I want you to stick to now on is called the distributive property, and we perform the distributive property. Sorry, I'm taking that negative inside of the bracket, and I want you to draw arrows from that -1 to the 7y, and another arrow to the -4. Okay, so we're drawing 2 arrows. And what we're going to do is distribute that -1 to everything inside the brackets. So think of the -1 as a hammer. And I want you to, so whatever's outside of the brackets, that's a hammer. Everything inside the brackets are little nails. The hammer has to hit each nail. The hammer has to hit each nail in order for us to apply the distributive property. And what that looks like, so the first portion I've written in black, 3y plus 5, because nothing has to change there. The second portion, and let me just confirm this. Let's see that. So this -1, I think the colors on the smartboard are not showing up. So the -1, I'm going to multiply by -1 by positive 7y, and I'm going to multiply -1 by -4. It's very important for you to realize that the sign in front of the bracket, so the 7y is positive, so we're writing positive 7y. The -4 is negative. So the sign in front of the coefficient, or in front of the term, belongs to the term and has to be inside the brackets. And the -1 is outside of the bracket, so it has to be written outside of the bracket. But what operation am I using to combine -1 and positive 7y? When you see a bracket, what operation does that imply, Saran? Multiplication. Thank you very much. So we're going to multiply those terms. So I have 3y plus 5. -1 times positive 7y is negative 7y. -1 times -4 is positive 4. And that gives me this, positive 3y plus 5, negative 7y plus 4. Now, this is the exact same sentence, but I have circled the like terms. So this goes back to Unit 5, where we have to rewrite the equation with the like terms right next to each other. So that means I'm rewriting the equation with 3y and negative 7y next to each other, positive 5 and positive 4 next to each other. Okay, So when we do this, we have to actually combine. So I didn't write 3y plus negative 7y. I just moved the negative 7y to be right next to the 3y. And I'm not moving just the 7y. I'm moving the negative because the negative belongs to the 7y. We cannot separate the term in front of the coefficient. That still belongs to that term, okay? So don't try to put in double signs there. Just move things around and look at combining the like terms. So 3y minus 7y. Can anyone tell me what that combines to? 3y minus 7y. Can anyone tell me? What's positive 3 minus 7? Thank you. Negative 4y. And positive 5 plus 4 gives me positive 9 as my final answer. So even though we learned that strategy of adding the opposite, try as much as possible in both Unit 5, if you haven't started Unit 5 already, Unit 5 and Unit 6, try to use the distributive property when there's a number in front of the brackets, okay, that you have to distribute. Even in grade 12, I asked my grade 12s, what's the next step, kids? And they say the distributive property. It's an essential tool that follows you all the way up till university or college. So you're going to get a lot of practice in this unit with this tool. Okay. One thing I want to just explain, because I had some questions about this, and maybe I will erase this. So the reason I put X's is that you're not supposed to do every single column in your Unit 5 and 6.
5, please have your agenda book signed and reported to English Department.
So you're only supposed to do the questions that correspond to your textbook. If you have that lizard on your textbook, that's called Mathematics Addison Wesley, and you would only do this column if you have the lizard in your textbook. That's the first column. If you have the Math Power 9, I think most of my grade 9 students have Math Power 9, you would only be doing the questions in the middle column. And I think most of Miss David's students have Principles of Math, then you would only be doing the questions in the third column. So I'll look at what textbook you have. That might mean that you and your friend have different textbooks, you're doing different questions. That's okay. The unit work is meant as practice, always to help prepare you for the test. If you don't feel like it's enough practice, you can always come see one of us and we will help you with more practice questions, right? Also, Khan Academy is another excellent resource that has, you can, IXL and Khan Academy actually, you can type in any topic and you can type in distributive property and you'll find a ton of questions. Okay. So this is another question that we might or might not have done in Unit 5, but this time we're going to be doing it just by applying the distributive property. So I want to see everyone writing these questions down, please. 4x plus 3 minus bracket 7x plus 2. Now, notice there's no number, there's just a sign. So I want to go in and write -1. In front of the bracket. So I'm remembering that I'm multiplying everything in the second set of brackets by -1. What does that look like? Again, I'm writing 4x plus 3 in black because nothing is changing there. I'm taking my -1 and multiplying by the first term, taking -1 again and multiplying by my second term. Brackets mean multiplication. I don't want to see the multiplication sign, please, because the multiplication sign can be confused with the term x. And you see how often we use x in the equation. So you want to make sure that you're consistently using brackets for multiplication. 4x plus 3, -1 times 7x is -7x. Negative 1 times 2. Is this the exact same problem, actually? I am not. No, it's a little bit different. Sorry, I saw the 7 and I thought it was the same problem. We rearrange now according to like terms. So we put all of the x's next to each other, all of the constant numbers next to each other. It's very important that I say positive 3, negative 2. The negative belongs to the 2. If you don't rearrange correctly, you're not going to get the final answer. In this case, it's negative 3x plus 1. That's for my grade 9 students. I've been reinforcing from day 1. Integer rules, integer rules, integer rules. You will not be allowed to use a calculator on this test, so you should not be using a calculator when you do your homework, because then you're not using that calculator in your brain. You've got to practice trying to calculate integer rules in your brain, because there aren't calculators allowed on math tests in high school. And if you don't practice that, if you rely on your calculator, then it's going to make it very difficult when you come to the test time. Okay, so we're going to put this as a try your own on your own. Please just write it down for now. I want you to try this on your own, and then I'm going to go through the solution. Here we have 3 types of letters, X, Y, and Z. Maybe with the person next to you, you can kind of compare notes. At least practice how you're going to write this out. Okay, so how you would write this out, you would have 3x plus y minus 4z. You wouldn't change anything about that, but you would take the negative 1, multiply it by the 7x. Negative 1 multiplied by 3y, negative 1 multiplied by negative 2z. Hopefully everyone wrote that out. I'm going to zoom out a little bit so we can see the whole solution better. So my next step would actually be to classify the like terms. I know on the smartboard right now you can't tell because the bulb is not showing up the colors properly, but in the notes, I've color coded. The Y's are in purple, the Z's are in red, and the X's are in blue. So you'll be able to see this when Miss David and myself, when we post the seminar notes. And then you're going to group the like terms next to each other. So positive 3x and negative 7x are next to each other. Positive y, negative 3y are next to each other. Negative 4z, positive 2z are combined because those are like terms. And because there are 3 different variables, 3 different letters, you should have 3 different answers because x's can only be combined with x's, y's can only be combined with y's, and z terms can only be combined with z terms. So that is when we are multiplying everything by -1, and I think Ms. David also covered that in the last seminar. Now we're going to move on to distributive property when there are numbers in front of the brackets that we have to distribute. So let's see what I have here. That's another complex question where you're distributing twice. You have -1 multiplied by the second set of brackets, -1 multiplied by the third set of brackets. But I'm going to let you go through this question on your own. This would be an example of a very challenging question on your test. Okay, let's do this question. So I have a rectangle. I have 5 being my length, and 4x plus 2 is represented by my width. How do I find the area of a rectangular object? Yes? That is, no, that's, I think you're talking about triangles. Anyone else? Yep. Length times width. Yes, length times width. So if we wrote our area formula out, if everyone can do that, it's a length, number 5, constant number 5, times my width, 4x plus 2. And you can actually write down that the area of a rectangle is length times width. But how do we use the distributive property now to solve this? That is the main question. How do we use the distributive property to solve this? So that's what we're going to explore. Give you a second to copy that down. Okay, and can everyone take a second and write down the definition of the distributive property? In this definition, we're going to represent some number, the number that's in front of the brackets, by the term A. So the A is my hammer. Everything inside my brackets are the nails. So the hammer has to hit each of the nails. That means that that number A has to be multiplied by everything inside the brackets. So when you apply the distributive property, you are getting rid of the brackets by multiplying everything inside the brackets by the term in front of the brackets. Oops, I didn't mean to do that. So by the term in front of the brackets. So please write that in your definition, and we are going to solve for the area in a second. I'm going to keep the definition up there for those of you who are not done copying, but I'm going to show how we solve for this particular question. So what I don't want you to do is just go from the question to the answer. That's a big no. I don't want to just see the answer. I want to see the steps of your distributive property. I want you to show me how you got the answer. That is the most important thing when we're checking your unit work. So if I have my question, the positive 5 is going to be what I distribute. So I have to rewrite the question as positive 5 times the first term, which is positive 4x, and then positive 5 times my second term, which is positive 2. At this point, I can perform the multiplication. So I'll just move over here. Positive 5 times 4x gives me 20x. Positive 5 times positive 2 gives me positive 10. Can I combine 20x and positive 10? Are those like terms? No. I can only combine an x with an x, a constant number with a constant number. So that I can leave that as an expression. My final answer is an expression. That means in order to find the area, I can substitute any value, different values of x to get different areas. So we use algebra to figure out a general expression so that when we substitute individual dimensions, we can get different areas to solve this question. So algebra is used in the real world quite often, mostly with inequalities and budgeting. That's something we're going to explore later on in the course. But in order to explore those concepts, we do need to reinforce your algebraic skills, and distributive property is one of those important skills. So, to another question that is similar. So I have the question, and let me zoom in a little bit more so you can see this. Can everyone write in your notes? My A term this time is 2. 2 is being distributed to my bracket, 5x plus 3. 2 times 5x plus 3. Now, some of you can just do this in your head. I know I can do it in my head, but that's not what I want to see in your unit work. I want to see the distributive property. So 2 times 5x, positive 2, so positive 2, I should mention that. This is a positive. So positive 2 times 5x, positive 2 times 3. Can someone tell me what positive 2 times 5x is? What is the answer to that? Yep. 10x. Yes, positive 10x. And I've revealed the answer by mistake. Positive 10x, positive 6. Now, I have little check marks, 2 check marks for that and 1 check mark over there. What do those check marks represent? What do you think those check marks represent, Saran? The marks that you would get on the test. So if you just wrote down the answer, you would only get 1 mark. But if you write down the steps, you would get 3 marks for the entire question, okay? So that tells you that your steps are more important than your answer. It's very easy to make a miscalculation and have your answer be incorrect, but your steps are the majority. Even in grade 12, your steps are the majority of the points for that question, okay? So if I send you back because your steps aren't there, please know I'm just trying to help you improve and do better. Here's a question where our A term is -2. Can you write that down, please? And there's a note here. Make sure to include the negative sign when distributing the -2. So I have -2 bracket 7x minus 4, close the bracket. So can everyone take a second, try this on your own, and let's see if you have the same steps and the same answer that I'm going to show you in a second. Okay? Try it on your own. How would you show your steps? So I'm thinking that we're throws it out. Okay, so your step should have been -2 times positive 7x, -2 times -4. The signs in front of those terms are just as important as the terms itself. Signs in front of the coefficient. And so that should give you a final answer of -14x plus 8. Okay, how many people got that right? Yay, excellent. Okay, let's go to a more complicated question. This time we have a trinomial inside the brackets. Trinomial because inside of the brackets we have 2x squared, -5x, +4, 3 different terms. Now, before I distribute, can the 2x squared be combined with the -5x? Can they be combined? They both have x's in them. Why can't they be combined? Someone tell me. Why can't they be combined? Yeah. Yes. In order for something to be like terms, they have to have the same variable as well as the same exponent. So we can't combine anything. What we can do is apply the distributive property. So I'm going to take that -3, multiply it by the first term, +2x squared, -3 multiplied by the second term, -5x, and -3 multiplied by the third term, +4. So take a second, write that down, and try to do the multiplication before I do, okay? Take a second, practice that internal calculator that you have in your brain. I'm ready, but okay, when you multiply the first set, what did you get? -3 times 2x squared. What is that? Yes. 6x squared. Good. -6x squared. That is correct. What about -3 times -5x? Negative and a negative make, yes?
A positive, so 15x.
Good. +15x. Excellent. -3 times +4. Last one. Constant number. Saran. -12. Amazing. Good job, grade 9s. Good job. So just like this, I don't want to see just the answer. I want to see you write out the distributive property. Okay. Now this is an example of a very complex distributive property question. Before we get to this, can you write it down? I just want to read the note. You can apply the distributive property to trinomials, but you can oh, that's not my note that I wanted. It says you can collect like terms, but the like terms have to be identical variables, same letters and same exponents. Notice this time we are doing the distributive property twice. First with the +2, and second, oh, that's too dark. And second with the +3, not allowing me to, +3, there we go. +2, then +3. So unlike before, you have to apply distributive property to both the binomials. We're going to do it twice. Let's see what that looks like. Step 1, apply the distributive property. I'm going to zoom out a little bit so I can see more of the equation. And I'm going to color code it. So +2 gets multiplied by my first term, 6m. +2 gets multiplied by my second term, -3m. Sorry, -3 by itself. +3 times the first term in the second bracket, +16. +3 times my second term, 4m. So we're applying the distributive property twice. Again, if the light bulb was working, you would see two different colors there. You will be able to see it in the video as well as in your seminar notes that are already published. So now we have to start combining. +2 times 6m gives me +12m. +2 times -3 is -6. +3 times 16 is +48. +3 times 4m is +12m. So I've applied the distributive property. That was complex. There is still one more step that I have to do now, and it's the reason I've drawn boxes around some of the terms. Can someone predict what is the next step that I have to do? Very good. Collecting like terms. So that might mean rearranging the question a little bit. So I'm rearranging +12m, +12m, -6 plus 48. I've written the like terms next to each other. By the time you get to grade 12, you won't really have to do that because you're going to have so many steps anyway. But it's always a useful skill to write the like terms next to each other because it's easy to for your brain to see something different and not group things correctly. Maybe my brain is going to see 12m and -12m, but when I'm forced to write it down, it reinforces what's really there. So I always recommend to please rewrite the equation with the like terms next to each other. So what is -6 plus 48? What is that going to give me? -6 plus 48. Yeah. Close. Negative. Oh, yeah. +42. You are correct. I'm wrong. You're correct. And 12m and 12m should give you 24m. So if you're comfortable with something like this, I'm telling you, you will ace the Unit 6 test. Okay. Unit 6 test is all distributive property, distributive property, distributive property, and with a little bit of collecting like terms. So there's a reason why we didn't put this all on one test. Unit 5 is collecting like terms to get you comfortable with just collecting like terms. Unit 6 throws in distributive property where you still have to go back and collect like terms. I have written some questions down in case, let's see, I put this in the seminar notes as well. Oh yeah, no. I really want to go over this before. How much time do we have, Miss David? 17 minutes. Okay, we have some time. Before we get to this, I'll actually go back for some extra. How many people still have to write their Unit 5 math test? Okay, so at the end of the seminar, I'm just going to go back to the previous slide and give you some practice questions that you can write down. It'll help you practice before your test. That's what we usually do for hallway math. We did that last year when we were in quads, but anyway, we haven't had time for hallway math this year. So this is a question, an example, where the term outside of the brackets that we are distributing is a variable. It's not a number, which makes things a little bit complicated. Now, when you see an x, what is the power that is automatically associated with x by itself? What is that number? 1. X to the power of 1. Good. So our first step is to write x to the, so you don't just go to the final answer. X to the power of 1 times x to the power of 2, x to the power of 1 times negative 3. So I'm going to give you a second to figure out how you would write this. If this appeared on the test, how would you write this? And then I'm going to show you how I would do that. So take a minute and write that out. That's this question. Okay, so very important, kids, that when you're showing your steps, you're also showing what you do with your powers, okay? So not just arriving at the answer, but showing that x to the power of 1 and x to the power of 2, you have to keep the base the same and add your exponents, and that helps you get the final answer of x cubed minus 3x. Okay, so showing your steps, just remember, kids, I'm recording, so it's picking up voices, okay? Let's take it one step further and let's get a little bit more complicated. Sorry, I keep blocking you. Let's do this question with negative x. So, negative x times 7x minus 4. That gives me negative x to the power of 1 times 7x, negative x to the power of 1 times negative 4. Now that negative x is the same thing as negative 1 times x to the power of 1, like that. There's an imaginary negative 1 there. So when we're multiplying our numbers, negative 1 times 7 gives me negative 7. X to the power of 1, and there is an x to the power of 1 here. Those two powers have to be added. And negative x to the power of 1 and negative 4 gives times negative 4, gives me positive 4x. So I'm going to attach, you don't have to take pictures because I'm attaching all of this right under your lessons, Unit 5, Unit 6 lessons. You will have this file with everything there. Anything we write in seminars will be available to you right after the seminar is done, or the seminars are done. So you don't have to worry about that. And yes, finally, sorry, I forgot to actually add the powers. So negative 7x to the power of 1 plus 1 gives me negative 7x squared plus 4x. Please feel feel free when you're making your study notes for your test. That means, so don't write cheat notes on top of your test. The test center really won't appreciate that. It's study notes that you're bringing in with your test. You can include examples from the seminar, right? These are examples that could come up on your test or could be very helpful for you on your test. So feel free to include them, but I want everyone to make sure that you are looking at these examples when you're doing your unit work. So here we have a trinomial again. It's a complex question because not only are we distributing the -3, we're distributing -3x. Every time I write a question, it gets a little bit more difficult, and I'm not going to be able to go through all of the examples I have, but feel free to do that on your own to go through the rest of the examples. So step 1, I'm going to make sure I write -3x to the power of 1, and I have to multiply it by the first term, the second term, and the third term. Step 2, I actually have to combine these. So let's do that. -3 times +2, I'm writing that down, keeping the base the same and adding the exponents. Next term, -3 times -5, keeping the base the same and adding, oops, that I didn't mean to do, adding the exponents. And finally, -3 times +4, keeping the base the same and combining it with x to the power of 1. Now that's complex to do. It's complex to remember to do that because you're applying distributive property and you're using the power laws that we learned in Unit 2. And finally, if I actually multiply, -3 times 2 is -6. Add my powers, I get -6x to the power of 3. Second term, -3 times -5 is +15. Add my powers, x to the power of 1 plus 1 gives me x to the power of 2. And -3 times 4 is -12. And I keep my x to the power of 1. Okay, so that's a very, very challenging question. But if you have a strong understanding of power rules, if you have a strong understanding of collecting like terms and now distributive property, that's combining all the skills you've learned since September together in order to do a question like this. What's important to remember about mathematics is that we have to continuously build. If the skills from before are weak, then you're not going to be able to build on it. Okay, very last thing before you go. There might be, I think this might have been part of the academic unit, so there might not be a lot of this on your test. But please be aware that you can distribute fractions. I can take this 1/2 and I can multiply it and distribute the fraction. I can take -2/3 and I can multiply it, distribute the fraction. So distributive property can also be performed with fractions. I know fractions are not the most popular topic in everyone's books, but for units, I believe, Miss David, is it unit 7? Yes, unit 7, when we're going to have to move on to a new topic called solving algebraic equations, where you're going to have a left-hand side and a right-hand side. You are going to have to work with fractions. So fractions are something that is going to be introduced in detail in the next unit. Okay, So that's it for today. Please make sure that you're always paying attention on day 5 and day 10 to make sure if it's not a repeat seminar, if our announcement is not saying repeat seminar, then you can feel free to come to the next one. But so the next seminar you're going to be attending is Unit 7, Part 1. Unit 7, Part 1. Thank you, everyone. Have a great day.